here we see Claude computer use control cursor autonomously to build a tower defense game across many iterations. We are asking it to ask cursor to build a defense game, and then it starts going. As you can see, it takes a screenshot and tries to determine whether the text input box is at the top or bottom, because the first message is going to be at the top. Here, it moved the cursor over here and inserted this instruction, and now cursor actually is building this sped up video, tower defense game and requirements.txt, and now the computer use actually found the text box at the bottom, and now it's going to write in here, as you can see, at a tower class with position attack range. Its first prompt was a more general one, and now it's actually building on it, and you can see the tower defense.py right here at the top left. Here we go. So now it's sending a second message. It's building it. Tower defense game is being written now, and at the same time, it actually prepared a third prompt and inserted it, and just in time, we will be able to send it. This is all done autonomously by the computer use. And I had given this computer use about 20 iterations to run with. So it's getting to its limit. Actually, here in a moment, it's going to be done. Actually, it ended before it was able to make another request. But after this tower defense game is done, it's applied. And now we're going to run it manually. And as you can see, it's actually pretty good and it works. Okay, now we're going to take a look at a more advanced version. Now we are actually going to do the same thing where computer use is going to control cursor. But as a matter of fact, this time we will actually have cursor use tools. I came up with a way to actually give cursor tools, and these reside in tools.py file, and it's a perplexity API search. And we're going to ask computer use to ask cursor to do research with 3 questions one by one to analyze NVIDIA stock and write the results to .md files. The project files, by the way, are available at my Patreon. Links for the major ones will be in the description because we're going to be doing quite a lot of demos. So when we run this, again, computer use starts, takes a screenshot, finds the top text input box, inserts its question. It says research NVIDIA's latest quarterly financial performance, create a detailed markdown. Okay. And now the cool thing here is, look at this. So now cursor, because of its cursor rules file, which we will take a look at, knows that it has a tool. And it wants to actually call this web search tool with this query, NVIDIA Q3 2003 quarterly earnings. Now, but here's the thing. Here's this run command. And I'm going to actually find it, the one at the bottom. Just watch. There we go. And it's going to click it automatically and run this command. And this will return the search results. And actually now it's writing the .md file, and you can see it at the top left. So not only that we are using computer use to control cursor, but we are giving cursor composer agents tools. So you can give as many tools as you like. We're going to actually take a look at the files more closely here. Let's continue. Okay. So now the first one is done. Now actually computer use actually moves the cursor to the bottom, because now the text input box is at the bottom. It clicks in it and it enters the second query, and to write it in NVIDIA market analysis. Let's see what happens. It's going to go and click on the command, as you can see, and now it's running the command. And after we're writing NVIDIA market analysis.md right here. So this is lovely, and it ran out of its max actions again because I forgot. That's fine. So, but now you can imagine it like this, right? We turn cursor composer agent is already an agent, but we're giving it now additional abilities that it doesn't usually have, such as perplexity search. You can give it any tools into this tools.py. Take a quick look at it. So here we have the tools.py file. This just has a function, web search, which takes in a query. And when we call and in the .cursor rules file, we describe it as this tool, just like we do when we do regular function calling. And then we instructed to actually run this, since composer agent can execute actions. So we instructed to do it in a particular way, not just run it with Python main.py, not run the file, but actually use the terminal commands to import the function from tools.py and run it with a query. So it's pretty remarkable that it can do that. So now let's take a look at our next example. So this is also exciting. But before we continue, I do want to say these 3 files you see are available at my Patreon. I will put the link in the description and in the comments. You can find it from there. But we will be taking a look at the code, the system messages, and the cursor rules file. So here, I've created a file called use yourself, and the computer use resides under this inside a function. So now, and I've instructed cursor rules. You can actually read the cursor rules that it can actually use the use yourself function from useyourself.py. Just like we have called the perplexity function, we can actually do it. We can actually call computer use through it. So actually what cursor is going to do in an inception style, it's going to call the tool which will use itself. What happens? So we are asking it to use yourself, to instruct the use yourself function to instruct you to build a tower defense game in Pygame. So let that settle in for a moment. Very mind-bending. So look, here it's using the Python, and it's importing from use yourself, import use yourself. And after that, it's using async.io to run the use yourself. With these instructions, I am cursor. Please instruct me to create a comprehensive tower defense game using Pygame. The game should include a game with defined path for enemies to follow, different types of defensive towers that can be placed by the player, blah, blah. Okay, so that's the thing. Now, we run this run command at this point, but after we run this here, the computer use takes over and is actually now controlling, and it will actually brought the cursor down here to the bottom. Yeah, it's instructing it, create a tower defense game, and it gave all the instructions. And now it also clicked on the send. It sent the message. And now cursor is working on it. And after it's completed, we simply run it. And as you can see, this also works. Really lovely stuff. Actually, let's skip the more simple examples because this is simple enough. Let's talk about first how we can get cursor to call tools. So you can do this any way you like, but the way I did it is I created a tools.py file. And you need to have a function in this file which takes in the type of query that you're looking for. Here, if you're going to do web research, we want to pass in a query. So you just want to design the function properly. This just calls the perplexity API. That's all it does. The next part is the .cursor rules file. Now, we don't want cursor to create a script to run this function because it has a tendency to do that. We just wanted it to run the function that we created because we want to be in charge of the variables, right? Because cursor can do it every which way, and we already know how we want to do it. So that's why we start with please do not run any terminal commands to run files. We don't want it to do that. Plus, we don't want it to do that as far as we're concerned because we're using the computer use. We want everything to be very tightly packed together. And the computer use has restrictions too, which we'll talk about here in a moment. But however, you can run terminal commands to run functions as instructed below. So we wanted to run terminal commands to run functions, which are its tools. You have tools as functions you can use in the tools.py file, which is this we have taken a look at. Yeah, so current tools it only has one tool, web search, but there's no limit to, you can have as many functions here as possible. As long as you define your tools here, you'll be good to go. Web search. Use this anytime you need any additional information. You're not allowed to create .py scripts to use these functions because it will have a tendency to do that. Just run the tools with a terminal command by importing and running them with a parameter in the terminal as Python, such as this. Now, if your functions are async, make sure to also ask it to await them. Okay, so this is the part, right? When we have this, we can actually ask it. So you don't need computer use for this. We can say, what is the NVIDIA stock price, let's say. And when we ask it, look, see, okay, I didn't run the agent. We want to run it as an agent. I just was using the traditional composer. Here we go. See, it's imported from tools. It imports the web search, and then it runs it with NVIDIA current stock price. Then we make our API request, and we get our answer, and then Cursor answers it. So we can, at this point, ask it to write it to file, do a report for us, search for multiple things. Those are all within the realm of reality. Now, let's move on to computer use.py. So this is quite a long script, and I'm going to get my AI code reviewer to go over it. The important part here is that we are restricting its action space. So we don't want, first of all, this is the way I thought about it, that we don't want computer use to go outside of cursor, do all kinds of things. We just want it very limited and only to use cursor and in a limited way. So I wanted it to be able to detect this text input box when it's at the top, and sometimes after we send a message, it moves at the bottom and do that. And so that's it. That's all we need. So I actually designed it to have initial coordinates and then also target coordinates, the regular coordinates, and run command coordinates. Because when we ask it to run a command for us, like search for NVIDIA, let me run this, search for NVIDIA, and run it as an agent. When it runs this, it's going to create a command. Here, when it creates a command, it has this run command. So that's another one of our coordinates, the run command coordinate. And we don't know where this is going to appear in the screen because this can be above, middle, or below. But this will always appear right here. So we are instructing it to use these three coordinates, essentially. So we want it to be able to just send messages and run commands. That's it. And we have max iteration. It also has a fully autonomous mode and not. You can also give it instructions midway through when it's done. And we also limit its action space to only move mouse, left click, type key, and screenshot. So it cannot do many other things. We just don't want it to leave cursor. We just want it to control cursor. Essentially, that's our idea. And also we have wait after screenshot. So as you can imagine, computer use is not 100% reliable. Maybe it's not even 70% reliable, especially in an environment it doesn't understand and it doesn't really know about cursor. It does know about VS Code, but it doesn't know about Composer. So anyway, that's why we just give it an artificial wait after screenshot. We allow it to take a screenshot only after it has sent a message. And we give it a 5-second delay. And let's just move on to the system message. That is where things get interesting. So we essentially ask it to say that you're a programmer using code editor called Cursor. Let me close this. You are specialized in AI assistant. You're a specialized AI assistant that can only click in the text input areas and the blue run command button when needed. Move and left click at the coordinates. You can only use these coordinates, either the initial coordinates when the text input box is at the top, the bottom one, or the run command. And type instructions into the Cursor code editor, press enter to submit, and take screenshots. So essentially, you can just send messages and run the commands. So to find the coordinates for this, I actually wrote a script that can get coordinates. When you run the script, it'll ask you to click anywhere. You just come here, click it. It'll give you the coordinates. If you want the scale coordinates, you click here, for example. It's the scale coordinates for that, and you click here, and then it gives you the coordinates for that. I should have been clear that you don't want the original coordinates, but the scaled coordinates. So once you have them, you bring them in the computer use. If you download the script, and like I said, these are available at my Patreon, you insert them both as a string and as a tuple, each one, the initial coordinates of the top input box, coordinates of the bottom, and then the run command. Yeah, that's it. And this also has project understanding. We have a function here that actually reads the .py files other than the computer use.py, get coordinates.py. So it can actually understand what it's doing. And your action cycle should be when you first begin to take a screenshot to determine if the empty text input box is at the top or bottom of the composer panel. So it needs to decide that. And I think we are also handling that. Uh, if it's at the top, use the initial coordinates to click. That's why we use the text. If it's at the bottom, use the regular coordinates. After the first action, you will always use the coordinates to click. So after the first action, the text input box will always be at the bottom. So if this is the beginning of your actions, most likely it's at the top. Text input box is gray, while the rest of the panel is black. Always return coordinates with left click action. These are just some things I had to figure out while building it. Move to and click at coordinates or at initial coordinates depending on where the empty text input box is. This is the action cycle. Type your instruction for cursor agent without using any new line characters until you are ready to submit, because it will new line character will be considered as an enter. It will initiate. We don't want that. Press enter to submit. Take screenshots to verify your action. So this part is important. You must continually keep taking screenshots if there is no blue button at the bottom right of the screen with a label accept or accept all. So it doesn't really follow that when with cursor agent, when it has done something, a blue button will appear here. So you can play around more with it. Essentially, we are trying to say that, okay, don't send messages if the cursor is still working, right? But I found out that it's better to handle this with by managing the wait after screenshot. And honestly, maybe 20 seconds is probably a better alternative there. You just give it some time, essentially. Okay. And this one is important. If in your screenshot you see a blue button on the right-hand side of the screen towards the middle vertically with a label run command, then you must click that button to submit your instructions using the run command coordinates. You must click these run command buttons when they're on the screen, as they're essential to the process, because you can skip this step sometimes. So as you can see, this is it's not exactly rocket science. It's a bit of a dice roll. Sometimes it'll do, sometimes it not. But honestly, when you restrict it like this, I think it works well 90% of the time, perhaps. So strict limitations. You can only use these actions. You can only click, right? You must verify these actions. So there's, I'll just scroll and you can take a look. So this is it. I was really happy to do this. I worked on this for 20 hours with only 4 hours of sleep. Now I'm making the video. I hope you enjoyed this as well and you found it useful. Now I'll let my AI code explainer explain this particular code. And you can also download, so there'll be 3 files, where one with the inception, where cursor actually calls the computer use. Another one where we just allow computer use to control cursor. And another one, the most advanced one, the one I like the most, which is this one, where the computer use can control cursor, plus we have the tools, along with the cursor rules file and everything. I hope you enjoyed this, and thank you. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses, and my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
The code begins by importing essential libraries required for various functionalities, such as async operations, GUI automation, file handling, and system interactions. Next, a series of constants are defined to specify initial coordinates and other parameters used for GUI automation. These coordinates help determine where on the screen certain actions will occur, notably clicking in specific areas, such as a text input box or a run command button. All these actions are crucial for interacting autonomously with the application UI. The code then sets general parameters for automation, including max iterations and safety messages. It's essential to have these to ensure your machine doesn't run away from you while you're not looking. It also configures PyAutoGUI, a Python module that allows you to control the mouse and keyboard to not fail when the mouse is moved to the corner of the screen and to have a slight pause between each action to keep things human-paced. This segment is fundamentally about setting the stage for safe and efficient automation of tasks by constraining actions to specific and safe operations. In this segment, the code defines literal types for actions and commands, delineating what sort of interactions can take place or commands can be executed. This is akin to a to-do list for the script, ensuring it knows precisely what tasks it's allowed to perform. Actions are primarily concerned with user type interactions like clicks, types, and screen captures, simulating what a user might physically do, but with robotic precision and no coffee breaks. Commands, on the other hand, relate to manipulating files on the system, such as viewing, creating, or editing files, which is crucial for a program that interacts with a coding environment. Additionally, the class resolution is defined to handle screen resolutions, which is necessary for appropriately scaling screen interactions to fit different display configurations. The established max scaling targets then ensure that the actions are compatible with typical screen resolutions, whether you're still living in the 4:3 past XGA or embracing the widescreen future. This configuration is key to ensuring the script behaves predictably across varying hardware setups. Here we have two key functionalities that significantly support the overall framework of the application. Firstly, the Get Python Files function is on a quest to interrogate all Python files within the directory, except for some specifically excluded files, and returns their content. It's a handy tool for creating a snapshot of your project's current state, the code equivalent of a family album. Secondly, the tool result data class represents the results of any tool operation used within the system, encapsulating success messages, errors, image data, and system-level messages. Thanks to its immutable and versatile nature, it can make your life easier when you need predictable outputs from tool calls. It comes with built-in convenience methods to evaluate its state easily and replace specific fields when needed. Together, these utilities help in managing and maintaining the state of file interactions and tool operation responses, ensuring the software can seamlessly interact with the coding environment and handle file-related operations gracefully. In this segment, the tool error class and computer tool class come into play, forming the backbone of error handling and GUI interaction within the application. The tool error class is your friendly neighborhood custom exception, designed to store messages specific to tool errors. It extends Python's standard exception class and aims to provide clear error messages when things go awry, which can prevent hours of debugging later. The computer tool class is more than just a tool. It's an orchestral conductor, coordinating a symphony of mouse and keyboard actions. It allows the script to interface with the computer's GUI, handling mouse movements, clicks, keyboard inputs, and screenshot captures effectively. It's a tech maestro that scales these moves to match the real-world resolution using a virtual resolution as a reference point, ensuring actions are executed with pixel-perfect accuracy, keeping your pixels right where they belong. The constructor of Computer Tool identifies the actual screen size and sets up a target resolution for scaling, ensuring any scripted interaction is dynamically adjusted to fit the screen, thus making it flexible across different screen sizes. This is vital for an application intended to automate interactions across varied hardware environments. This segment of the computer tool class defines an important method that acts like a universal remote for executing GUI actions. The call method allows you to specify an action from the action type and optionally inputs coordinates or other parameters to simulate user interactions with the computer interface. First, the magical method validates if the action requested is allowed, like asking if someone can attend the secret club of GUI operations. If the action doesn't have a golden ticket, allowed actions, it raises a tool error, very much like a bouncer refusing entry. Next, the code processes coordinates to verify and scale them. It ensures that certain actions, like left click or mouse move, have required coordinates before converting them into a suitable format. It takes input coordinates and scales them to the screen's physical dimensions, allowing the script to interact with actual screen positions. This method is crucial in the script as it ensures each GUI action is validated, scaled correctly, and executed methodically. Whether it's clicking, typing, or moving the mouse ensures that every command adheres to the constraints and functions smoothly, making sure your virtual assistant doesn't try to click out of bounds. This snippet continues the call method of the computer tool class, where it handles more GUI-focused actions such as typing text, clicking various mouse buttons, and taking screenshots. For text-related actions, key and type, it ensures there is valid text to input and uses relevant libraries to simulate typing keys or entering text with controlled speed. It's the script's way of typing sans the typos or needing caffeine breaks. Mouse clicks are similarly structured, with a click map that dispatches the correct click function. It makes it as satisfying as hearing that click on a remote control. Additionally, it supports functions like retrieving the current cursor position by converting it back to virtual coordinates and capturing screenshots. Screenshots can be essential for verifying actions visually, crucial in ensuring that automated interactions are performing as expected. After executing a main action, except for checking the cursor's position, it captures a verification screenshot. This elegant choreography ensures each interface interaction is traceable and verifiable. Methods, scale coordinates, and inverse scale coordinates ensure that any coordinate calculations convert seamlessly between virtual and actual screen dimensions, allowing the entire suite of actions to be adaptable and precise across different screen resolutions. This code segment is about capturing screenshots and representing them in a way suitable for digital communication, followed by a new class introduction for handling file manipulations. The Take Screenshot function skillfully takes screenshots, resizes them to a virtual resolution, and encodes them in base 64. This last part is critical for transmitting images as text strings, a format often required for web services or API interactions. If anything goes wrong, useful error messages are encapsulated in tool result, which is the catch-all response system for the program. There's also a helper method, getActionDescription, that translates action commands into human-friendly descriptions, which is more for our delight than the computer's utility, but is invaluable in logging and debugging, ensuring we understand what actions are being prepared. Moving on to the Edit tool class, it manages file editing tasks like viewing files, creating new ones, and text replacements. This tool helps in modifying code files indirectly through automated interactions. It tracks every edit made so it can be reversed if necessary, an undo button for file changes. This meticulous tracking is notable for keeping the editing safe and reversible, much like an apprentice baker trailing behind with a broom. The Edit tool class's defining method, call, handles various file operations such as viewing, creating, and editing files. It adds a helpful organizational layer by maintaining a history of edits akin to a digital historian for every file it touches. The method ensures that all file paths are absolute, avoiding relative paths, which are no good for navigation. With an historically accurate backup of each file interaction, it executes commands like create, which assists in making new files, view, which just shows the contents possibly of a file, or star replace, which intelligently replaces specific text. For star replace, it checks if the string exists, whether it's singularly present, and then dives into the textual surgery. String replacement operations are held to high standards, only performing when assured of correctness. Only one copy of the string must exist. Similar checks and operations are carried out for inserting strings in specific lines. The method format_output enriches output, formatting contents with line numbers, a boon for tracking and visibility, reminiscent of the teacher pulling out red ink to highlight what line needs improvement. All these operations cement Edit tool as an adept assistant in file management, offering robust control over text changes while ensuring nothing gets lost to the ether of system history. Computer Control API class serves as the main orchestrator of the application's functionality by providing a high-level interface for controlling the computer through a combination of interactions with Claude API from Anthropic and the tools defined earlier, Computer Tool and Edit tool. Upon initialization, it sets up all necessary components, such as authentication with the Claude API, and prepares the tool instances for controlling the computer and editing text files. This is where Anthropic tools meet the brute but obedient power of automation. The run conversation method is a core metaphorical dance conductor that ensures smooth interaction between user inputs and automated actions. It starts by collecting user input, cheekily asking for commands, and preparing them for processing. As it processes each request loop, it sends communication back and forth with the API, performing actions through our trusty tool classes, incrementing interaction counts, and managing conversation flow keenly like a bartender, making sure everything is perfect, each mix right. This class plays the role of mediator between the user prompt, API responses, and tool execution, dramatically heightening the flexibility and usability of this automated system. In this part of the run conversation method, the magic of API interaction happens, where the real exchange with the Cloud Dynamo Claude API unfolds through a series of serialized communicative exchanges. The API call with the create method sets its sights on engaging our tools and provided system prompt using messages from the user, tools, and defined parameters. Like laying down the tiles of a conversation path, it sends input carefully until it reaches the receptor end of the assistant. Post-response processing follows as the assistant Claude's plan is showcased. It inspects each piece of the response, classifying them, and preparing tool-specific actions, the script's very own to-do list. Tool actions, if any, are gathered, and the script prepares for more, potentially non-existent interface tasks. It plans every step methodically, similar to preparing for a voyage into uncharted code. In the event of no actions needing execution, the configuration cleverly defaults to autonomous continued processing or queries for user intervention, ensuring that operation remains seamless. No ship without a captain here. The strategic handling keeps the operation in progress unless an explicit user decision is made to pause or stop. This tantalizing segment of code is where the action requested by the assistant is actually executed on your computer through the tools we've established. It's like the moment in a spy movie where the gadgetry springs into life. The function iterates over each planned tool call, executing relevant logic based on what should be done, like a detective executing his plan of arrest gracefully but confidently. Each execution is vetted for errors with results formatted into digestible tool result structures. If something goes wrong, you better believe it won't happen quietly. If errors are found, they are gracefully added to the results to ensure that no mistake is left hidden, akin to finding a misstep in your misstep. It also manages the continuation of operations, examining if the automatic modes should carry forward, prompting further user statements, and ensures control is delicately shifted back to the human overseer if needed. By the end, it creates a conversation flow that's smooth and synchronized, ensuring each piece fits perfectly into the larger puzzle of interaction. In this segment, there are several vital components addressing error handling, tool result formatting, and system prompt orchestration. Error handling ensures even if the script is accidentally provided with junk, it doesn't explode into a million syntax errors. It catches exceptions, providing a friendly user interrupt if the user decides to intervene with a good old Control-C. The format tool result method polishes the tool outputs, ensuring they are suitable for returning to the API. Each output is wrapped in specific formatting, handling text, errors, and images with the expected API formats. Additionally, the getSystemPrompt method builds a system-level capability prompt. Within it, project files are gathered for context and capabilities are explicitly predefined, a call to arms for the bot. Filled with constraints and limitations, this prompt prevents the assistant from stepping beyond its bounds, tailored to fit our use case snugly. It's the script for our computational actor, ensuring it knows its role, its lines, and doesn't wander off the stage into the audience. In this snippet, the Use Yourself function provides a high-level mechanism for executing the computer assistant with predefined instructions. This script feels like you're setting up an understated but finely tuned instrument, triggering sequences of dynamic but gentle automation. Upon invocation, the function begins by warning the user about the potential impacts of running the script, humorously cautioning them to flex those observation muscles. With artificial delays configured, it pauses just long enough for humans to intervene if the computer starts showing signs of a rebellious nature. The function harnesses the power of PyAutoGUI, configured safely to simulate a human-like behavior with potentially shorter coffee breaks. An API key is sought, either from the parameters or environment variables, underscoring its dependency on the Anthropic API for operation. Once initialized, the core of the communication begins, a recurring loop that uses API client interactions to execute the assistant's plans, dynamically evaluating the assistant's returned blocks and queuing actions to be performed. This method is essential to launch the overarching processing flow of the script, calling on the rest of the defined classes and methods to fulfill its tasks, much like recruiting diligent minions to carry out the whims of a mindful supervisor. This continuation of the use yourself function emphasizes seamless termination and error handling, closing off our programmatic escapade with grace. If no tool actions are required, it gingerly closes the operation, emphasizing the zen of automation when all tasks are complete. When there are tasks to be done, it proceeds with executing each, obtaining results, handling errors, and outputting results or logging issues, a cyclical march of computer control. Ensuring thorough error handling, it also employs sleep intervals between tasks to maintain a smooth rhythm of execution, reminiscent of a computer needing a brief nap between tasks. Finally, by logging any exceptional occurrences and gracefully closing upon user interrupts or general errors, it reinforces stability and reliability. Ending the session is not just a line of text. It is an assurance that the assistant fulfills tasks without leaving untied ends or mysterious errors. As the grand finale, this segment defines the main asynchronous function, serving as the primary entry point for the assistant. It sets up and calls the Computer Control API, initiating the run sequence of operation. Using environmental variables to source sensitive API keys ensures security, only proceeding when validated keys are in place, watchmen guarding the gates of API access. The wrap-up includes basic error handling and debug toggles to allow or suppress verbose error logging. This main thread is surrounded by a typical main check, aligning execution flow for this script, keeping non-lethal errors in check while outputting their details only when explicitly told to do so. Throughout, a considerate approach is taken to prevent unexpected crashes, echoing a safety-first mantra by reminding us to manage API keys securely and providing the tranquility of a friendly on-screen termination message when interrupted, preventing sudden scare.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000X Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.
Now, listen to me. I've been trying to code, and I like coding. The fact that I can code and make things happen, but how do I do it? I mean, fast with AI. I'd heard about it. It's easy. So, I came across 1000X Cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000X your coding.